Welcome everyone to aha-vts.com KLIPcast on configuring VRRP. My name is Alim H. And oh, by the way, I'm the handsome gentleman to the right. And in this KLIPcast, we'll be discussing what is the Virtual Router Redundancy Protocol and configuring VRRP in a basic network design. So, let's get started. The Virtual Router Redundancy Protocol, or VRRP, is a network protocol which provision can be used for automatic, transparent assignments of available routers on your network. Now, these routers will act as a default gateway for your host on a particular network of subnetworks. VRRP falls under the umbrella of First Hop Redundancy Protocol, or FHRP. And this suite of protocols also includes HSRP, GLBP, CARP, and etc. Now, the protocol itself is designed to increase the availability and reliability of routing paths. This is achieved by creating virtual routers and labeling them as master and backup routers acting as a group, which means a host on a network is assigned to the virtual router instead of the actual physical router's interface. So if a physical router is acting as the master, then that router will be forwarding packets on behalf of those clients. If that master fails, then the physical router acting as the backup will be selected automatically to replace that. So looking at my diagram here, if router WX is the master on this Ethernet segment, then router WX will be forwarding packets on behalf of host A, B, C, and D. If router WX fails, then router YZ will become the master and begin forwarding packets on behalf of those clients. And I hope that makes a little bit more sense now. So let's go ahead and begin building and configuring this VRP network, and let's see what I say holds true. Okay, now looking at my diagram, I have three routers labeled WX, AB, and EF. And I have four hosts on this subnetwork of 20.0.0.0/24. And this overall network has been pre-configured for simplicity's sake in OSPF Area 0. Now, the intent is to show almost seamless gateway redundancy with respect to end users when trying to reach the loopback 0 on router EF with the IP address of 1.1.1.1/32. So first off, traffic should flow from our host towards router WX because that will be our VRRP master. And the traffic should go towards router EF and then hit loopback 0. I'll then go ahead and shut down the fast Ethernet interface on router WX on the subnetwork, and hopefully and transparently, the traffic will begin to flow towards router AB, then towards router EF, and then hit our loopback 0. And there's one more thing. There is a group IP address that is shared between our VRP devices. This group address will act as a default gateway for our hosts on this subnetwork. And that group address we'll be using is 20.0.0.254/24. Okay, so let's go ahead and bring up our devices. I'll bring up router WX and then router AB. And since router WX will be acting as our VRP master, I think I'll start there first. Okay, and here are the following commands that I'll be inputting. Alright, so first off, go into global configuration mode, followed by the interface that is connecting to our 20/24 subnetwork, and that's fast Ethernet 0/0. I'll hit the question mark here, scroll down a bit, and then I will type in VRRP, followed by our group number. In this case, for simplicity's sake, I'll choose 1, followed by IP, and then the IP address, or the group IP address for VRRP. And that group address is 20.0.0.254. And let's see if there's anything else to input. Secondary, no, we're not doing that, so I'll just hit enter. Next, I'll type in VRRP, and as you may have noticed, two status messages popped up. It's saying that fast Ethernet 0/0 group 1 status has went from initial to backup, and then went from state backup to master. So currently, right now, router WX is the VRP master. So where was I? Typing in VRP, followed by the group number 1, and then I'll issue preempt. See if there's anything else? No. And I'll hit enter here. Then I'll type in VRP again, to group number, and this time I will type in priority. Now, the priority number ranges from 1 to 254, and this designates the device's ability to become a VRP master on this network. So the higher the value, the better chances that it'll become the master. And since WX is the master, I think I'll type in 200. If there's anything else? Nope. Then I'll hit enter and enter. And there we have it. I'll do a write mem here. And then I will issue show VRP brief. And here we see that the interface is fast Ethernet 0/0. The group identification is 1. The priority is 200. The designated time is 3218. The state is master. The master's address is 20.0.0.5, which is fast Ethernet 0/0. And the group address, which is a default gateway for our hosts, is 20.0.0.254. Okay, great. Next, I'll input show VRP to show a little bit more statistics. Now, just like the brief, we have the state as master. Now we see the virtual IP address as well as the MAC address. We notice that preemption is enabled, the priority is 200, and the master router is 20.0.0.5, which is local to us, and we show the master's advertisement interval and the master down interval. Great. So now let's go ahead and configure router AB. Similar inputs as we did for router WX. So the first thing is I go into global configuration mode. Then under the interface participating in the subnetwork, which is fast Ethernet 0/0, type in VRP, followed by the group number, which will be 1 because it must match the VRP master. Then IP, followed by the IP address of the group address, which is 20.0.0.254. I'll hit enter. Then I'll type in VRP 1, and you notice the status message. Now it's indicating for router AB that the state went from initial to backup. That's great. So VRP1 followed by preempt and enter. Then VRP1 and then priority. In this case, since the master is 200, I think I'll give this a slightly lower priority of 190. Now you may be asking, what is default priority on these devices? Well, for VRP, the default priority is 100. So I'll hit enter here, and that's it. Exit out of here, type write mem, and there we go. So now on router AB, I'll do a show VRP. I think I'll do this one first. Now we see that on router AB, the status is backup. The virtual IP address and MAC address is similar to that on router WX. Preemption is enabled. The priority is 190, and the master router is 20.0.0.5 with a priority of 200. Excellent. So now I'll issue show VRP brief and similar information that we showed previously. Great. So far, VRP is working. Okay, so let me bring up our test devices here. Got PC1 and PC4. So we start on PC1 first. So now let's go ahead and try to ping 1.1.1.1. As you can see, I tried it before, and that host, well, is unreachable because our gateway 20.0.0.254 was not available. Now it is. Let's see if we can ping it now. Okay, so I'll issue ping 1.1.1.1, and let's see what happens. All right, so now we can get to loopback 0 on router EF from PC1. Now the question is that we have here, which way is it going? Is it going through router WX or AB? Well, To answer that, let's go ahead and trace it. So I'll enter trace 1.1.1.1. Let's see what we get. All right. So now looking at this, the first hop is 20.0.0.5, which is fast Ethernet 0/0 on router WX. And the next hop is 30.0.0.1, which is the gigabit 1/0 interface on router EF. So yes, it is going the way we would like it to go initially through a VRP master on router WX. Excellent. So now let's go ahead and shut down the interface on router WX and let's see what happens. So let me bring up our routers again. Now I'm going to use PC4 this time. I'm going to issue an extended ping and we'll see what happens on PC4 as well as on our routers. Okay, so we have a continuous ping going. Now go on router WX, config T, then interface fast Ethernet 0/0. Now I'm going to shut down the interface. So we have to try to look at 3 different term prompts at the moment. So we're going to shut. Let's see what happens. All right, so we see the first status message that WX is no longer the master. It went to init, and I am not sure if there was a hiccup in the ping on PC4, but we see a status message on router AB saying that it went from state backup to state master. So let's go ahead and stop this ping. Okay, and I'm going to scroll up on PC4 and let's see if we saw any hiccups. Okay, we also see that our neighbor relationship between router WX and AB is down. So let's see, I started the ping there. Wow, it was pretty much seamless. Okay, no timeouts. So now, staying on PC4, let's go ahead and trace it and see if it's going through router AB. Okay, and according to this trace route, it is going through router AB. So 20.0.0.6, which is the IP address of fast Ethernet 0/0 on router AB. And the next hop is 40.0.0.1, which is gigabit interface 2/0 on router EF. So yes, it has failed over and router AB is the VRP master. You can verify that by going to router AB and typing in show VRP, and as you can see, the state is master and the master router is local. Now let's go ahead and take a look at router WX and let's see what happens here. So I'll do a show VRP, and you notice that the state is init and the master router is unknown, and the reason for that is there's no heartbeat information going between router WX and AB to determine who is the master. So great, failover have worked properly. However, we are faced with another issue. Let's just say that the interface between router WX and a subnet is okay. However, the circuit between EF and WX is no good. In this scenario, the advertisements between the master and the slave are fine, but upstream connectivity is lost. So what does that mean? Well, it means we created a black hole. Because the heartbeat between the master and the slave are fine, there's no need for router AB to transition to the master role. But we need this to occur. So what should we do? Well, we need some sort of mechanism that can track the upstream interface status, if you will. And this is done in global configuration through the use of the track command. So I'll jump on router WX, go into global configuration mode, then I'll issue track, followed by the tracking object identification number. I'll use 1, and then I will choose interface, and then the interface of choice, and it will be gigabit 1/0. See if there's anything else. we'll issue line protocol. And the line protocol command allows us to track the interface status as either up or down. See if there's anything else. Nope, I'll hit enter here. And now we're in track subconfiguration mode. Let's see if there's anything else we need to do here. No, I don't think so. So I'll exit out. Now, go back into global configuration mode. Then go under interface fast Ethernet 0/0 where we configured VRRP. I'll then issue VRP. Our group number is 1, followed by, this time, track, and then our tracking object identification number, which is 1. And then we have the decrement keyword. Now the decrement keyword will reduce the priority that we have configured on router WX by a certain parameter. And that number ranges between 1 and 255. Since we configured router WX with a priority of 200 and router AB with a priority of 190, we need to decrement router WX's priority to be less than that of the priority on router AB. So for our purposes, I will enter 30. So I'll decrement by value of 30 and enter. And there we have it. Okay. Before I leave, I am going to bring back up this interface because I previously shut it down. So I'll do a no shut here, and we should see a transition to the master role. And there we see the status message indicating that on router WX and on router AB, it transitioned from master back to backup. And also, our OSPF neighbor relationships came back up. Excellent. All right, so I'll bring back up our PCs, PC1 and PC4. So on PC1, I'll trace 1.1.1.1 to make sure it's flowing through router WX. All right, it's doing that. So now I'll issue a continuous ping again, and let's see what happens. Nope, it's a ping, not a trace. Okay. All right, so we have a continuous ping going. Now I'm going on router WX, then go into global configuration mode and the interface G1/0. And now I'm going to shut down this interface. What we should see is that the interface will go down, the decrementing of the VRP priority on router WX, and hopefully AB will become the master. So I will shut this interface down. Let's see what happens. Let's see if we see a hiccup on PC1 too. Okay, so we have 2 hiccups. All right, so line protocol went down and router WX transitioned from master to backup, and router AB transitioned from backup to master, and our ping is still continuing. So let me go ahead and stop this ping. Okay, and let's go ahead and take a look at these status messages we got here. So router WX, I'll get out of here, and then I'll show VRP. And we see that router WX is now the VRP backup, and the master router is 20.0.0.6 with a priority of 190. We notice right above that, the track object 1 state is down, and the decrement value is 30, which means that the priority on WX is now 170. Excellent, that's exactly what we wanted to see. Let's go ahead on router AB and issue the same thing, show VRP. All right, so the state is master, the priority is 190, and the master router is 20.0.0.6. To verify, let's go on, this time, on PC4 and issue that trace route, and let's see what we get now. All right, just the same thing as before. The first hop is 20.0.0.6, which is router AB, and 40.0.0.1, which is router EF G gigabit 2/0 interface. Excellent. Great. That's exactly what we wanted to see. Now, from a best practice standpoint, it's always best to configure VRP devices as both master and slave to each other, and to segment the host accordingly to take full advantage of the VRP capabilities. Well, it looks like we configured VRRP correctly on our network segment. However, it took a little bit longer than anticipated, and that's only because I added a few extra configurations to the overall KLIPcast. Well, in this KLIPcast, we talked about what is the Virtual Router Redundancy Protocol, and we configured VRRP on our network. I hope you enjoyed this KLIPcast on configuring VRRP, and I'd like to thank you for viewing.